Hey everybody, Mr. Rubo here. Today we are talking about solving rational equations. So these are going to be ones where you have a rational equation on one side equals to a rational equation on the other. Now with these guys, if there's any addition or subtraction of them or multiplication, you always want to simplify one side first until you get it to look like this. Now once you're at this point, you want to multiply by your denominators. So I'm going to multiply by x minus 7 to both sides. So when I do that, this is really like it's over 1. Same thing over here, but these will cancel, so you're left with 2. And on this side, I can multiply it out, so 3x minus 21 all over 5x. But now I want to multiply by 5x to both sides, because now those will cancel, and you get 3x minus 21 equals 10x, and it's become a two-step problem. Subtract the 3x from both sides and divide by 7, so we get x is negative 3. Now, a couple things. When we do this, you can usually do the multiplication in the same step, because we are going to multiply by both denominators. But I will say, depending on what the factors are, if you don't have any common factors, you don't have to multiply by as much. And you'll see in the next example. Now, the other thing you want to do, though, is you do want to make sure this answer works, because it is possible to have extraneous solutions. So you always want to check for those. So when you plug in a negative 3 here, you get 3 over negative 15, which is negative 1/5. Here, 2 over negative 3 minus 7, which is negative 10, which would again be negative 1/5. Which means we're good. All right. So now let's look at another example. So let's say we have 4x minus 4 all over x squared plus 2x minus 8 equals 4 over x plus 4. All right, so here I'm going to factor this right away. So this is actually going to factor to x plus 4, x minus 2. Now, something you should notice is both have an x plus 4. So let's multiply both sides by x plus 4. The reason I do that is because guess what? Oh, x plus 4s cancel out on both sides. And now all I have to do is multiply both sides by x minus 2. So this side, the x minus 2 will cancel. So the left side just becomes 4x minus 16 when I multiply out the top, and the other side becomes 4x minus 8. Okay, so that's something when they have common factors in the denominators, multiply by those first because those cancel out on both sides. All right, and now we start solving this. Well, first thing is to subtract the 4x. Well, it cancels out on both sides, which means we get an untrue statement, which means no solution. Okay, so that is a possibility to get no solution straight out, but it's also possible to get an extraneous solution. So let's see one where we're going to get extraneous, and let's see one where it's just a little bit more work involved. So we're going to say x plus 1 over 3x minus 6 equals 5x over 6 plus 1 over x minus 2. All right, so first thing here, we have the addition of two rationals, so we have to simplify this side to become one fraction, one rational expression. So we're missing 6's, so 6 over 6. This one we're missing x minus 2's, so I'm going to do that right there, and then I'm going to multiply it out. And then this left side, I'm just going to factor the denominator. So 3 and x minus 2. So on top, we get 5x squared minus 10x all over 6 times x minus 1. I'm sorry, x minus 2. Can't help if I can read my own writing. Plus 6 over 6 x minus 2, which means we're going to add the top. Well, when we add the top, it really just can't add anything truly together because there are no like terms. so it doesn't really change anything. So we get 5x squared minus 10x plus 6 all over 6 times x minus 2. Okay, so now when we look at this, x minus 2, clearly a factor on both sides. So let's multiply that. Now when it comes to the numbers, sometimes you may need to multiply by both numbers. Other times, like in this case, because they share a factor, and one of those factors is 3, we could just multiply by the bigger of the two, and both denominators will cancel out. Like I said, sometimes your goal is to cancel out your denominators. So whatever that takes, you do. Okay. So 6 cancels here, x minus 2 cancels here. So we're left with 5x squared minus 10x plus 6. On this side, x minus 2 cancels. 6 and 3 cancel, but still left with 2. So we have 2 times x plus 1. So it becomes 2x plus 2. Okay. Now it's a quadratic. Once you're a quadratic, you move stuff all over to one side and you try to factor. Oops, that's a plus 6. Oh, man, I'm doing great with my reading here. Or my writing, I should say. So 12x and then plus 4. I was going to say what I had there was interesting. So now this does factor to 5x minus 2 and x minus 2. So now we can get the two answers. So from the left factor, we get 2/5, and from this factor, we get just 2. But you have to check your solutions into the original, always the original. So the original is right here. It ends up 5/6 does work. Or, I'm sorry, 2/5. I saw the 5/6 up there. So this does work when you type it in and you simplify it. But when we get to the 2, I don't know why it keeps jumping up here. When we substitute 2 in to the original, and you can see it on either side, you get 3 times 2 is 6. 6 minus 6 is 0. You can't have 0 in the denominator, which means this right here is an extraneous solution. Okay? And that means it's not part of our solution set. But if you wanted to see which ones you can't have, it's always based off your denominator of your starting fractions. So here we can't have 2 because that will give us 0. Well, can't ever make 6 0, so that doesn't affect it. Here, x minus 2, 2 would also make this one 0. So really, if you got x equals 2 as an answer, that's going to be your extraneous solution. Okay. So yeah, thanks for watching, and have a good day.